In this video, we're going to look at solving quadratics by factoring. The beginning part of the video, though, is going to be just a basic overview of factoring. So if you're really good at factoring, you may want to just kind of skip over a little bit of that, or at least just kind of double check yourself. But our focus in this unit is not so much how to factor, but I feel like we need to review factoring just in case you don't quite remember all of that. Now, this is a review, so I'm going to kind of go through it pretty quickly, just do a couple of examples of each types of factoring that we've discussed. But I do have some other videos that you can watch that go a lot more into detail about how to factor. So the different types of factoring that we're going to look at are GCF, difference of squares, the AC method, where A is 1 and where A is not 1. All right, now there's several methods that you can use when A is not 1. Trial and error. Some people have like slip and slide, the airplane method. But I prefer something that's the grouping method. So when we get to that point, I'll show you that. So it may be a different method than maybe what you're used to. But you always check GCF first. So GCF is basically what number or variable or a combination of the two can be divided evenly into every single term in your problem. So in this particular example, we could divide out a 3. Now, you don't necessarily have to show dividing by 3, okay, but it helps some students to see that more visually. Okay, so 3 is my GCF, so don't drop it, and then that leaves us with 5x squared minus 3. All right, now for right now, I'm stopping there because we're just focusing on a review of factoring, and then I will show you how to solve that later. All right, so for the second example, we have a difference of squares. I have an even exponent. It's a subtraction problem, and 49 is a perfect square because 7 times 7. So I would have x plus 7 and then x minus 7. Another way to think about that is the AC method, because what can I multiply to get negative 49 that would give me nothing, 0, x in the middle? Well, 7 and negative 7 would zero out to give me a nothing or 0 in the middle, right? So you can kind of think about it that way too. This third example, it may be tempting to just go ahead and say, oh, everything's perfect squares. It's a difference of squares. But you always want to do GCF first. All right, so in this problem, I can divide out a 4. So I would have 4 times x squared minus 16. And then I want to go and do my difference of squares now. So I keep the 4. Remember, you don't just drop it. And then I would have x plus 4 and x minus 4. All right, so that one was an example that had a combination of a GCF and a difference of squares. All right, so now let's look at some AC methods. All right, so for AC methods, you always want to look, so we're going to do A times C. All right, so remember, standard form is AX squared plus BX plus C. So A times C would be what number is in front of the x squared and what number is your constant. So for the first example, 1 times negative 24 is negative 24. Well, what can I multiply to get negative 24 that will help me get that negative 10 that I need in the middle? All right, so you can kind of think through your factors, all right, but the two that may pop up the quickest are 6 and 4. But here's the problem, all right? In order to get negative 10 in the middle, these both have to be negative, right? Which gives me negative 10. But is a negative 6 times negative 4 still a negative 24? No, it's positive, right? So that does not work. So now we got to think of another way. Well, we've got 2 and 12, all right? Well, the only way to get a negative 10 would be for the 12 to be negative because the bigger number would have to be negative. Well, is 2 times negative 12 still negative 24? Yes. So these are my two factors. Now, the good thing about the A being 1 is you can go straight into your parentheses. So this would be x plus 2 and then x minus 12. So those are our two factors. Remember, factors are what you multiply to get something else, all right? And you could flip-flop these. You could say x minus 12 here and x plus 2 here, all right? And it's still the same thing. All right, so the second example, A times C would be 1 times 30, so that's 30. What can I multiply to get 30 that gives me a negative 13? Well, the one you'll probably think of first is 5 times 6. But 5 and 6 don't give me 13 or negative 13. So I got to think of something else. Another one you may think of is 2 times 15. Well, the only way for me to get negative 13 would be for that to be negative. Problem is, though, is a positive times a negative still positive? No. So I got to think of something else, right? So then I have 3 times 10. All right, well, both of those would have to be negative in order to get a negative 13. And is a negative times a negative here positive? Yes. So these are the two factors. So I'd go straight to my parentheses, x minus 3, x minus 10. Again, I could have said x minus 10 and then x minus 3. All right. So you don't necessarily have to write down every factor, but just start writing them down and start thinking, well, does this one work? If it works, awesome, stop. If it doesn't, then keep going. All right, now this last example, I really intended for this G not to be here. So I'm going to kind of scribble out that G. Okay, so on your notes paper, if you're following along on my notes guide, just scribble out that last G. All right, but the first thing I would want to do here, though, is look for a GCF. And all three of these terms can be divided by 3. If I had left the G there, I could have divided by a 3G, okay? But I have intentions here. All right, so I'm going to keep the 3. And what that leaves me with is G squared minus 8G minus 20. All right, so I need to see, can I factor this some more? It has a GCF, but does it also have the AC method? So A times C would be 1 times negative 20. Is there anything I can multiply to get negative 20 that would give me a negative 8 in the middle? So I'm thinking, 5 times 4, no. 1 times 20, no. What about 2 times 10? Well, the 10 would have to be negative. So 2 and negative 10 give me negative 8, and 2 times negative 10 gives me the negative 20 that I need. So these work. So I keep the 3. Remember, we don't just drop the GCF. But then the other part would factor as an X. Well, I guess it's a G this time. So I'll fix that. All right, G plus 2, and then G minus 10. All right, so that's your AC method. And then this last one, of course, had a combination of a GCF and the AC method. All right, so then the last method is when A is not 1. Okay, and now this last example has a GCF, so we'll deal with that. But these two do not have a GCF. All right, so I'm still going to use the same steps as I did before with the AC method. So 4 times 9 is 36. What can you multiply to get 36 that gives you a 12 in the middle? All right, so you got, let's see, 2 and 18, 3 and 12, 4 and 9, 6 and 6. All right. And they would both be positive to get the 12 in the middle. So this is the grouping method. The grouping method takes this middle term and it replaces it with those two factors. So I'm going to have 4x squared plus 6x plus 6x plus 9. All right, so for grouping, you split the problem into 2 groups. You have your first group and you have your second group. So you're going to do a GCF on both sides. So on the first side, I'd factor out, a 2x, all right, which would give me 2x times 2x plus 3. On the right side, I'm factoring out a 3. So I write down the 3, and that leaves me with a 2x plus 3. Now, in order for this to be accurate, whatever's in parentheses has to be the same, okay? So, and then you're basically doing it again. You're like how you did a GCF on the left, a GCF on the right. Now you're going to do a GCF again. What do they have in common? Well, the parentheses. So the parentheses gets written down one time, and then you're left with the 2x and the positive 3 that's right here. Let me point to it, these two. All right, so I had the 2x plus 3 that they had in common from the parentheses, and then the 2x and the positive 3 that was not in parentheses. That was kind of my leftover. Another way to rewrite this would be 2x plus 3 squared, okay? So that is one example of the grouping method. All right, so this next example, 2 times negative 15 is negative 30. What can you multiply to get negative 30 that will give you a 7 in the middle? And so it's going to be 10 and 3, but the 3 has to be negative because 10 minus 3 is 7, and then a positive times negative gives me that negative 30 I need in the middle. So I'm going to replace my middle term with those two factors. So I'm going to have 2x squared plus 10x minus 3x minus 15. I'm going to split my problem in the middle. All right, and then I'm going to have a GCF of 2x on the left. So I'm going to write down 2x times x plus 5 because that's what's left over. And on the right, this is a common mistake. Somebody's going to want to divide out just a 3. So I'm messing up, okay? If I put 3 here, that would leave me with negative x minus 5. Are these the same? No. So that tells me I made a mistake. So instead, I want to divide out a negative 3. So if this number here happens to be negative, you do need to divide out a negative. So I'm going to divide out a negative 3, and that leaves me with a positive x and a positive 5. Now my parentheses match. So I pull that out. So my x plus 5 is what they have in common, and what they have left over is a 2x and a minus 3. So 2x minus 3. So those are my factors. All right. Now the last example here has a GCF, right? So we have to do that first. All right. So the GCF is, let's see, 2. All right, because 6 doesn't go into 10. So we would factor out a 2. And that would leave me with 2 times 3m squared plus 5m minus 12. All right, so now my AC is not 6 times negative 24. My AC is 3 times negative 12, which is negative 36. And what can I multiply to get negative 36, which gives me a 5 in the middle? And it would be 9 and negative 4. So I'm going to replace this middle term with my two factors. So I'm going to keep the 2, okay? Like I'm going to circle it real big. I'm going to kind of forget about it for a little while, but I don't want to forget about it forever. All right, so I'm going to replace my middle term. So I have 3m squared plus 9m minus 4m minus 12. I'm going to divide my problem into 2 parts. The GCF on the left is a 3m. So I have 3m, and I have an m plus 3 left over. On the right side, pay attention, that's a negative, right? So we're going to divide out a negative 4, which leaves me with m plus 3. My parentheses are the same, so we keep the parentheses, right? And then what's left over? Well, we have a 3m and a minus 4. So 3m minus 4. And then don't forget about this GCF here. That 2 comes back. All right, so that is our factored answer. All right, so that is a quick review of factoring. So now I want to extend this. So we want to extend it to solving. So with solving, you're going to factor fully. Make sure it's in standard form first. Okay, you want everything on one side of your equal sign, so it should be equal to 0. Factor fully, and then set each factor equal to 0 and solve. So for this first example, my AC would be 18. So I would multiply, and I'd have a negative 2 times a negative 9. All right, so I would have m minus 2 and m minus 9 equals 0. And then set each of those equal to 0 and solve for x. So I'm going to do a little bit of mental math here, but if I add 2, I get 2. If I add 9, I get 9. All right, so ultimately my sign is just changing. All right, for this next one, it's not in standard form, right? Because it has 2t squared equals all of this. So we're going to have to get everything on one side of our equal sign. So I want to keep my leading coefficient positive though. So I'm going to subtract 16t and subtract 40 from both sides. All right, so subtract 16t, subtract 40 from both sides. So I get 2t squared minus 16t minus 40 equals 0. There is a GCF, so I'm going to pull out a 2. So I would have t squared minus 8t minus 10. And then I got to factor that again. All right, so AC is negative 10. And I could multiply, let's see. Can I multiply anything? Let's see. 2 times 5, 1 times 10, no. All right, so really this would have probably some imaginary solutions or some decimal solutions. All right, so we have not learned the quadratic formula yet, so I'm going to kind of save that for later. So this would have more to come. Oh, you know what happened? I messed up. Maybe somebody caught it. Maybe somebody didn't. Let's try to go backwards. Hold on. All right. This should be a minus 20. It's amazing what one number can do. All right. So my AC would be negative 20, and I could multiply a negative 10 and a positive 2. So this would give me a t minus 10 and a t plus 2. So my solutions, 2 equals 0, that doesn't work. So I don't use that. All right, but then I would have a t equals a positive 10 and a t equals a negative 2. So I consolidated a lot of steps. I did a lot of mental math, but I kind of thought to myself, okay, if I were to set that equal to, 0 and solve for x, I'd have to add 10 to both sides. I'd have to subtract 2 from both sides. Okay, so I did a lot of mental math there. This last example, we would factor out the r, and we would have r minus 6 left over. So I'd set each equal to 0, so r equals 0 and r minus 6 equals 0. R is equal to 0, that's okay. And then here, if I added 6, I would get r equals 6. So we have two solutions, 0 and 6. All right, last two examples. This first one would factor as h plus 5, h minus 5, because that's difference of squares. So I'm going to do a lot of mental math here, but if I set it equal to 0, I'd get negative 5. If I set this one equal to 0, I'd get positive 5. So you could look at it separately, or you could say plus and minus 5. Either one of those would be fine. The last one is grouping. So I would have negative 24, and I would multiply a positive 8 and a negative 3 to get the 5 in the middle. So I'm replacing this middle term. So I would have 2x squared plus 8x minus 3x minus 12. Split it in the middle, factor out the 2x. So I have x plus 4 left over, factor out a negative 3, and I'd have x plus 4 left over. My x plus 4s are the same, so I can feel pretty comfortable that I've done it properly. So x plus 4, and then I have a 2x minus 3. All of that's equal to 0. So if I set x plus 4 equal to 0, I just get negative 4. That's one of my solutions. But 2x minus 3 equals 0, I'd have to add 3 to both sides, and then I'd have to divide by 2. So x would be 3 halves, or 1.5. All right, but those are my two solutions. All right, so that's factoring. I'll do the complex factoring on a different video because this one is already long enough.